Before we solve our combination circuit, let's review the basic rules for series and parallel circuit. First, series. Good. First, let's talk about series circuit. In a series circuit, there's only one path. For the electrons to flow into. Because there is only one path, the current is the same throughout every resistor. Right? So when you're solving for the current in a series circuit, the current is the same throughout every resistor. And now to find total resistance, we simply just add the resistance together. And so on and so forth. And the total voltage is equal to the sum of the voltage drop across the resistor. So the voltage is equal to the sum of the voltage drops across each one of the resistors. So it's just like this: V1 and V2. Now these are the standard series relationship: same current, additive resistance, and voltage drops adding to the source voltage. Now let's look at the parallel circuit. Okay, in a parallel circuit, there are multiple paths for the current to flow. And the most important rule to remember is that the voltage is same across each parallel branch. So the formula for voltage total voltage is just this, because the voltage is same throughout all the branches, and so on and so forth. But the current splits between the branches, so it's this: IT I1 plus I2, and so on and so forth. For the resistors, if there is a 2 resistor in a parallel, exactly 2 resistors in a parallel, we can use this formula. Notice that we are multiplying 2 resistance on top and adding them on the bottom. Parallel branches share the same voltage while their branches current add to the total current. Now, we need one more important formula: the Ohm's law. What is Ohm's law? The Ohm's law is the formula for the voltage resistance and the current. If you want to find the voltage, you have to do this formula. V stands for voltage, I stands for current, and R stands for resistance. Now, if you want to find the current, this is the formula. And now, if you want to find the resistor, here is the formula. This is important in finding each one of the voltage of the resistor or the current or the resistance. Now moving on is the most important part, the combination circuit, which we are tackling for this lesson. It is a combination of series and parallel circuit. So what happens is, when a circuit has both series and parallel section, that is called combination circuit. We can't just use the series rules or just the parallel rules for the entire circuit. Instead, we identify each section and use the correct rule for that section. We simplify the easiest section first, replace it with its equivalent resistance, and then continue simplifying the circuit. Once we find all of the total voltage, total current, and total resistance, now we're gonna use the Ohm's law in order to find each of the resistors, voltage, current, and resistance. And now we know the rules for the combination circuit. Now it's time to solve one of these problems. Now that we know all the rules of the series, parallel, and combination circuit, now let's try to solve this problem. This is the voltage. The voltage is 30V. The resistance 1 is 5 ohms. The resistor 2 is 6 ohms. Now the R3 is 14 ohms and the R4 is 3 ohms. Now what we're gonna find is the IT, I1, I2, I3, and I4 on this each resistors. Why I1, I2, I3, I4 specifically? Because we need to find each of the current passing through each resistor. And now we gotta find the voltage 2 and the voltage 1, voltage 2, voltage 3, and voltage 4 passing on these resistors. So we need to calculate how many voltage is passing through the resistor within these given ohms. And last but not the least, since we now let's go to the solving our circuit step by step. First, let's identify the connections. The R2 and R3 are connected, so therefore they are parallel. And the R1 and the R4 are a series because they only have one path. Now we're breaking that into simple steps now. Now let's find the first one, the R2 and R3. Since in the rules we tackled the formula for finding the R total if there are only two branches. So this is the formula. R2 3 is equal to R2 R3 and now let's see our values and substitute it to our formula. The R2 is 6 ohms. As you can see, the R3 is 14 ohms. Now let's solve it. 6 times 14 is equal to 84. 6 plus 14 is now equal to 20. And now we divide it. 84 divided by 20 is equal to 4.2 ohms. So therefore, the equivalent of resistance 2 and 3 is gonna be 4.2 ohms. Now let's cross this out. Now let's add a new one, which is the solved one. R2 3 is equal to 4.2 ohms. Okay. Now that we have all the resistance, we can do this now. R1 is equal to 5 ohms. R2 3 is equal to 4.2 ohms. R4 is going to be 3 ohms. Now the circuit is much simpler because these three resistors are now in series, so we just add them together. So this is the formula for the series for the total resistance. RT equal R1 plus the R23 plus R4. And now we substitute them. The 5 from R1, 4.2 from R23, and 3 ohms from R4. So our total resistance will be 12.2 ohms. Therefore, the total resistance of the circuit is 12.2 ohms. Like this. Okay. Let's simplify it. Okay, now let's put the R total. Okay, now the total resistance is 12.2, and now we gotta find the total current. Now that we know the total resistance, we can find now the total current using the Ohm's law. This is the formula for finding the total current. Now we can substitute it. The voltage total will be 30 because it's already given. And now the 12.2 ohms, and now we divide it up, and the approximate will be 2.46 current. So the total current coming from the battery is approximately 2.46 amperes. Now this is the standard next step after reducing the combination circuit to its total resistance. Now the next step will be to find the I1 and I4. Let's put it here. 2.46 amperes. And now we gotta find the I1 and I4. Now we're going to work backward through the original circuit. R1 and R4 is series with the parallel section. Remember, current is the same throughout the components in the circuit. So therefore, if the I total is 2.46, the I1 would be 2.46 amperes. Then the I4, it is still the same because they are series, so it's gonna be 2.46 amperes. So the current through R1 and R4 is approximately 2.46 amperes. Now we got this. Remove this. Okay, now we gotta find the V1. Now let's find the voltage across R1. The formula we need to use is the Ohm's law, which, can I do this? This one indicates what resistors we're gonna use or substitute. Since the I1 is 2.46 and the resistance for R1 is 5 volts, we can times it, which is gonna be approximately, wait, I forget the approximate, equals 12.30 volts. So therefore the voltage across the R1 is approximately 12.30 volts. Wait, let me just fix this. For more space. And now we need to write it here. V1 is equal to approximately to 12.30 volts. So the voltage across R1 is approximately 12.30 volts. And now, what's next to V1 is V4. We're gonna find the voltage across the resistor 4. Now we'll just do the same thing as we did for volt 1 for finding the V1, like this. V4 equal, we need to get the current for 4 is 2.46. Now we need to find the ohms, the ohms for R. The ohms for R4 is 3 ohms. Okay, so you see that. Now we gotta times it. So 2.46 times 3 is approximately to 7.38 volts. So that is the volts across the resistor of the voltage. So the voltage across R4 is approximately 7.38 volts. So we can write it here, 7.38 volts. Okay. Now after we did the finding the voltage across the series circuit, now we gotta find the voltage across the parallel circuit. We gotta find the voltage across them. Okay, the battery gives us 30 volts in total, so VT equal 30 volts. We already used approximately 12.30 volts across R1 and 7.38 volts across R4. So this is the formula for finding the voltage across voltage 2 and 3. Total minus V1 minus V4. So we substitute it. This is the formula. Substitute. The V total is 30 voltage. The V1 is 12.30 volts. Now the V4 is 7.38. Now we minus it. It will be it will be approximately 10.32 volts. So the voltage across the entire parallel section is approximately 10.32 volts. Now we gotta find the volts across each of them. We gotta find the R2 and R3 volts, because in the rule we said that in a parallel section or circuit, all the volts are same across the branches. So therefore V2 is equal to V3. So therefore V2 will also be 10.32 V, and V3 is 10.32 V2. So we can write it down here. V2 10.32 V, V3 is equal to 10.32 V. So both R2 and R3 have approximately 10.30 volts across them. And now we got to find the current in each of these resistors. First, we got to find the current for the resistor 2. So we know that in Ohm's law, this is the formula for finding the current. So we substitute the numbers. The V2 is 10.32 the R2 is 4.2, but the given is 6, so therefore it's 6 ohms. Okay, as we can see, and now we have to divide it. So I2 is approximately 1.72A. So the current running to R2 is approximately 1.72 amperes. And now we know the I2, so we put it over here. Oh, I have no space, bro. There. Now we remove this. And what's next of I2 is we gotta find the I3 now. This, since we know, we gotta just substitute it. It's just like the I2, 10.32, and now the ohms for I3 is 14 ohms. Substitute it, divide. I3 is approximately 0.74 amperes. So we know that I3 is approximately 0.74. So it's 0.74 amperes. So the current running to I2 is 1.72, and the current running to I3 is 0.74. And now, before we finish, let's check our answers. The current through the parallel branches should add up to the total current. So this is the formula. I2 plus I3 must add up to the total current. So the I2 first is 1.72 amperes, and the I3 is 0.74 amperes, and the total current is 2.46 amperes. And now we add these two up, and they must exactly add up to 2.46 and equalize. So if we add them up, they will be actually 2.46 amperes, which is the same as the total current. So the answer checks out. The two branches current adds up to our total current. That's an important check because current entering a parallel junction equals the sum of the branches current. We can also check the voltage. So the current is done. Check the rest. Now we have to check the voltage. They must also add up to plus V4 equal VT. They must absolutely add up to the total voltage. So the V1 is 12.13 volts, and add up the voltage across 2.2 and 3 is 10.32. And now the voltage across resistor 4 is 7.38. The total voltage is 30 volts. And if we add them up, there will be 30 volts too. So this checks out. The voltage add up to 30 volts, which matches the battery's voltage. Now the total voltage is correct, and the resistance is correct. So this is our final answers. and we found the total resistance. Let's fact check our answers. Let's check if they are here. The R total, let's find it. It's over here, so we definitely find it. The I total, which is here, 2.46 amperes, we definitely found it. And the voltage total, which is 30V, found it. So the main thing to remember is identify the series and parallel section first, and simplify the easiest section first, and then work backward to the circuit. Once you practice this process, even a complex circuit becomes much easier to solve. Thus give you So this is the full solving flow. You need to first identify parallel equivalent, the total resistance, total current, and series. And next is current, series voltage, to parallel voltage, to branch current, and check. So this is it. Thank you for watching. I hope you learned something for today, and that is the lesson for combination circuit.